Okay, so just kind of check in where we are thing. Like, first of all, I don't know anything about weather stuff or what's gonna happen there. Usually we find out after you guys know, so if y'all hear something, if you could just let me know, that'd be very helpful. Only it's like the last possible second, like, I don't know. Like when everything went online for COVID in like March of 2020, we were on spring break that week and they emailed us on like Friday afternoon at the end of spring break. They're like, oh, by the way, Monday, you need to do everything online for 2 weeks. Like, oh, good. I feel really prepared for that. Okay, cool. And I had a 2-week-old baby. It doesn't matter anyway. Test force Friday. Whether we have school tomorrow or not, I don't know. But test force Friday. It's all the chapter 6 stuff. So exponentials and logs. Exponentials and logs. Homework stuff 6.3, which is logarithms and like log properties, basically stuff that we talked about a little bit last week and then Tuesday. That's due on Monday. 6.5, which is what we're going to be doing today and tomorrow and first couple of days of next week, and like that's the only new thing we have left to cover. That homework is set to be due on Thursday. The idea was that the test is Friday, right? So like you want to make sure that you know the stuff. At the same time, I don't want you like stressing about getting a homework grade done the night before the test when you have bigger stuff to worry about. So like you should be able to have this done in plenty of time well before then. But if it comes down to it and you need me to push it back a day so that you can finish the last problem or whatever, like I don't care about that. That's fine. Ultimately, that's not a big deal anyway, but if that needs to move, it can. But you should pretty much have everything that you need to be able to do the 6.5 homework by, the end of tomorrow, provided tomorrow happens, I guess. Okay. So that's where we are. There's a review up for the test now in Blackboard if you want to start looking ahead to stuff. Like I said, today and tomorrow we'll be kind of covering the stuff in 6.5, and then next week we've got 3 class days to review homework problems and practice and do whatever we need to make sure that we're locked in for Friday. Okay. But again, really make sure to take advantage of tutoring and office hours and help and all that kind of stuff. All right. So kind of a quick recap of stuff. We're going to see coming back in sort of a big important way, this idea of going back and forth between the exponential and the logarithm. So for example, 2 cubed is 8. Right, that's kind of an exponential statement. The equivalent logarithm would be the log base 2 of 8 is 3. Right, so you got a base. Think of this as the answer if you want, and an exponent. Then for the log, it's the base and the answer and the exponent. So another way to say that would be that a log tells you about an exponent that you don't know, right? So the log base 2 of 8 is saying, okay, well, what power of 2 is this number? Okay, well, the logarithm, that operation tells me that the answer is 3. That's the exponent that I would need on this number to give you that. Logs have some interesting properties because of what they are, right? Because that log is an exponent. I'll leave this where you can see everything. Because a log is an exponent, some things that we know from dealing with exponents, like multiplying like bases, you add the powers together, right? Well, that means if you take a logarithmic product, you can split them up and add the 2 logs separately instead, right? That's the product of logarithms. Quotients, same idea, but the opposite. If you're dividing, you can split and subtract. If you have a power inside a log, you can break it down like a coefficient, right? So the log of n copies of x would be the same thing as n copies of log. We're going to see all this stuff come up in the context of trying to solve equations. Way back last week, I don't know, when we first started talking about logs, and we did this like 1,000 times, right? So everybody kind of remember that, going back and forth between these things, or taking one of these and writing it as a log. And I'm almost certain that I said something like, if you can do this, even when there's an X or a fraction or it's messy or whatever, then you're going to be good to go. This is the payoff for that, because in solving equations, that's going to end up being sort of the key step to kind of cracking the whole thing open. We might have to do some stuff before, we might have to do some stuff after, but going from one to the other is going to be sort of the key to the whole thing. So take just a second when that gets to you and maybe think about how you would do that very first problem, the first example there. One more time, did anybody take the quiz on Tuesday and not get one back? Two and then they won. Okay, 7 to the x is 12. So we're trying to solve for this unknown power, right? 7 to some power I don't know equals 12. What can we do? Rewrite it. Just rewrite it as a log, right? What would that look like as a logarithm? A log base 7 of 12 equals x, and we're done, right? That is an exact solution. Your exact solution is going to be, in terms of a log that like doesn't clean up nicely. So this would be a place where, I mean, probably log base 7 of 12, you can recognize like that one's not going to, clean up in any kind of nice way, but this would be a place where I would probably just check, grab your calculator, take the log base 7 of 12. If it gives you some messy, horrible decimal thing, then just leave it as the log of 12. That's the exact solution. We got it just by rewriting the thing as a log. Now, logs being what they are, there are a bunch of equivalent ways you can write that. The log base 7 of 12 is the same thing as the log of 12 divided by the log of 7. That's common log or base 10 log. It's the same thing as the natural log of 12 divided by the natural log of 7. Any base that you want, as long as you use the same one on top and bottom, right? That's just that change of base formula. We're going from one base to another. Depending on what you look at, how you work through solving things, you could approach this in a different way and end up here. It's still correct, right? It's still the same solution. Man. Sorry. But again, that step, rewriting it as a log, was kind of the key thing. Okay, so if I've got an exponential term somewhere, if I can sort of get it by itself, right? Get it isolated so that I can kind of focus in on it. Then I can rewrite it as a log by just taking whatever the base was here to be the base of the log. And then again, those two things, the like answer and the exponent kind of swap, right? There might be stuff where we have work to do beforehand to get it kind of by itself, so we can do that. There might be stuff where we have work to do after to finish solving, but that's kind of, again, the key part of it. Sorry if I start talking. Just need a minute. Okay. Another way that we can think through that same idea that gets to the same place is a lot of times in solving, we want to look at things as like doing something to both sides, right? I've got an exponential thing here. If I want to solve, I need to undo the exponential thing. To undo something, you do the opposite, right? You apply its inverse. What's the opposite to an exponential? A log. So I could think about this as taking the log of both sides. In the same way that I would, add 3 to both sides or divide both sides by 1 or 5 or something, right? Like, okay, if I take a log over here, I'm going to be able to get rid of the exponential thing. But if I do it to one side, I got to do it to both. Really, what we're doing isn't any different except for maybe how we're thinking about it, right? Instead of like, because when I think about what we're doing here, I'm always kind of focusing in on the exponential part, and then everything kind of pivots around that, right? So this is kind of like anchoring things. Now, instead, I'm looking at it as, okay, well, to get rid of the exponential, I need to do a log. So I'm going to do a log there. But if I do a log there, I got to do a log here. Now, since I'm deciding that I want to do the log, I get to pick what kind. So what base do you want to use? Okay, I heard 10, I heard 12, I heard 7. Anybody want to argue their point? Okay, 12 is bigger. That's true. So if we do the log base 12, let's just walk through kind of what that would look like for all of these. If you do the log base 12, the thing on the right cleans out nicely, right? Log base 12 of 12 is 1. What about the thing on the left? It doesn't like cancel because the bases are different, right? So they're not inverses to each other. You can use the power rule to bring this down, right? So you have that, which is fine because that's just a number. Right, so if I divide both sides by that, we're good to go. That's fine. That's an answer. Is correct. Do you see now why maybe using base 7 would have been a good idea? What would happen if we'd chosen base 7? Yeah, if you do a base 7, and again, 12 wasn't wrong, right? What we just did is fine, it's correct. So if you have room to, copy them both down or whatever, then do that. If we did base 7 though, what happens on the left-hand side? The log base 7 of a power of 7 is just going to be whatever the power is, right? Those undo each other, those cancel. No, if you want to, think through, or if you want like another step in the middle there, think about this as coming down. So it's X times the log base 7 of 7. But that's just 1, right? Because it's how many 7s are in 7. So again, we just get X. So either, this undoes that and you just get the power, or if you want to think about using the power rule thing to bring it down, then that is just 1. Somebody said base 10, also like base 10 would work fine. Let's actually just run that real quick. Golly. 7 to the x equals 12. If we did base 10 or common log would look pretty similar, or natural log, I mean. Again, you can bring this down. And then what I would need to do to finish solving is divide. That's, again, exactly the same. It's equivalent to what we got before, right? So we did it 3 different ways with 3 different bases, but we ended up at the same place every time, right? Now, some of those, like to me, this feels like the most straightforward, right? Because the side where the exponential thing is happening kind of cleans up nicely, quicker, right? It kind of goes directly. This is fine too. The base 12 is fine. You can use, again, any base you want. Something like 5 would be a weird choice, but like you do you. The argument for using something like this is, again, that like, everything knows what log base 10 is. So you can get that. The way that the textbook or the help stuff in my MATLAB does it, it's going to do something like this with either a common log or a natural log, using just kind of those by default. So if you look at that, you'll see that. I'm going to pretty much work stuff this way. Because again, I like that, it makes one side kind of clean up faster. But that's kind of another way to think through what we're doing, just like take the log of both sides. So if you don't like the idea of just rewriting the thing as a log, if it makes more sense to you to think about, okay, do the opposite to one side, but then you got to do it to both, then that's, kind of this, right? Okay, so tell me about maybe that first practice problem there. Sorry, does anybody have any questions so far? Okay. All right, tell me about that. Log base 5 of 13 is X. And again, that is an exact solution, so we're done. This might be a place where you maybe grab your calculator real quick and make sure that this isn't, so I mean, again, at some point you'll kind of have a better sense for this maybe, but that 13 is not going to be a nice power of 5. But if this was, a big number or fraction, something like that, I might check just to make sure that it happens to be, 2.5 or something that's going to clean up, kind of okay. All right, so why don't you all take just a couple of minutes and try to do the same thing for 2 and 3. All right, what you got on 2? Log base, yeah, 1/3 of 6 is X. Now, again, there are equivalent ways to do that, right? There's not really any particular reason that you would change the base. You could, but that would work, right? Like it would be equivalent to say that the log base 3 of 6 is negative x, right? For example, because this thing is the same thing as 3 to the negative x. Not wrong, not really any reason to do that, but you can. Okay, how about 3? Yep, everybody agree? Okay. Now, there's something wrong with one of those. Does anybody see it? There's a negative inside the log, right, with that last one, which is undefined. Which means that this actually has no solution, right? So what we've been doing, and like one way to catch that would be, like I said a minute ago, just punch it in the calculator real quick, see if it cleans up nicely, like you're gonna kind of want to do that anyway. That would catch this, right? Because if you try to enter the log base 3 to negative 4, it's gonna give you some kind of error message. And if you look back at the original problem, you can see that, well, yeah, okay, of course, that doesn't make any sense. 3 to the x, exponential growth, horizontal asymptote of the x-axis. You're asking where is it equal to negative 4? I've run out of hands. Here's negative 4. Where is it equal to negative 4? It's not, right? Because it's always sitting above in the upper half of the plane. Well, okay, so if I sort of paid enough attention to this, I could have caught that anyway, that's going to have no solution. If you only, if you're strictly doing the like mechanical thing though, you might not always catch that stuff. So just kind of be aware, right? Because exponentials have sort of a restricted range. They only live some places. Or flip side of that, logs have a restricted domain. You can have some stuff like this kind of come up, right? We'll talk about that some more as we go, but just something to be aware of. Okay, so 4 is not all that different, even though it looks different. Where should we start there? Subtract 1. Yeah, good. Subtract the 1. That's low-hanging fruit. That's stuff that we can move away from the exponential, so it's not getting in the way and not confusing things and not leaving me with something where I got to decide, like, how does that affect things? We'll just get rid of it. In sort of the same vein, what else should we do? Be careful because this isn't 5e raised to the 3x minus 2. This is 5 times e raised to the 3x minus 2, right? Like this is the thing that's got a power on it. And if it helps you to, sort of split things up in the way you're writing it so that you can distinguish that better, then like do that. This is the only thing that's actually carrying the power, right? So this is the exponential thing with some power I don't know that I'd like to know more about. Before I can do that though, before I can do the log thing, before I can bring this down, I need to have this by itself, right? So divide by 5. So before you start doing, exponential turning it into a log or log turning it into an exponential stuff, you want to make sure that you have the thing that you're going to be sort of focused on, the thing that you're working with, have that by itself first, right? Isolate that because other stuff is going to do things that might not work the way that you want them to. I'll just say it that way. Okay. So everybody good with where we are right now? Okay. Now E raised to some power that I don't know, right? But e raised to some power that I'd like to know more about equals 6/5. How do we get this stuff out of the exponent? Say it again. We can't multiply it over. Can't multiply or divide. Can't do a root because I don't know what the power is, right? We have an exponential thing. We have a power that we don't know. How do you find a power that you don't know? With a logarithm, right? That's what a log does. A log tells you a power you don't know. Here's a power you don't know that you want to find. Do a log. What should the base be? E. So it's a natural log. So the ln of 6/5 is 3x minus 2. Remember that thing I said a minute ago about like if you can rewrite the exponential as a log even when it's not as pretty as 3 squared equals 9 or something? This is that, right? This is not any different than 3 squared equals 9 becoming the log base 3 of 9 equals 2, right? If you look at it as sort of a pattern, base raised to a power equals something. So log with the same base of the something equals the power. It's the same thing, right? It's just a little bit messier, right? It doesn't look quite as nice, but it's the same exact thing. So that's what I mean when I say if you can do this all the time, even when it's not pretty, that's what I mean. Okay. Natural log of 6/5. Jaden, can I borrow that for a second? Natural log 6 divided by 5, enter big jumbly decimal mess. That means I'm just going to leave it like it is. Okay. If it's something that it, comes out cleanly, I assume y'all know how to, switch your decimal to a fraction, stuff like that. If it comes out nice, then cool, go with that. If not, and a lot of times it won't, then just leave it like this. But this is just a number, right? So we've got 3x minus 2 equal to some other number. How do we solve for x? Move this over, so add 2 to both sides, and then move this over, so divide by 3. So that's all we're going to do. We're just solving a linear equation. We're going to add 2 to both sides. The difference is that when I add 2 to both sides, I can't combine those in a nice way. So I just got to leave it written out. That is the exact solution to this equation. It's not pretty, but that's what it is. Again, because it's a log, there are other equivalent ways to write it. So, if you look at the way somebody else works this out, it could be in different terms, but be the same value, right? I know that's always kind of weird, but that's a thing. This log. The big thing though, so say this is, hypothetical like test problem. What I'm going to be looking for is first you solve for this thing. Then again, kind of the big key thing is going from this to the equivalent log, because that's kind of the only way to get this stuff down. Right now, again, you can do that by just rewriting like we did here, or you can do it as taking the log of both sides, right? That would lead you to the same place, right? Because you would get stuff that cancels over here, you bring this down, you push stuff over, and then sort of finishing out solving. If I'm given 10 points for this problem, this step is probably half of them or close to it, right? Because again, that's the big sort of key thing for exponentials and logs is going from one to the other, right? And how that relationship works. Okay, questions? Feel medium okay? Okay, medium okay. All right. Okay, so if there's just sort of a single exponential thing in there, then we solve for it, then we get rid of it. Same thing will be true for a log, right? I would want to, get the log by itself and then get rid of it by going the other direction. What's different about something like number 5? There's 2 of them, right? There's an exponent on both sides. Well, we've seen some stuff where there's an exponential on both sides before, right? You've done some stuff in the homework where you had maybe something like this, which doesn't look all that different, but there is something different about it in like an important way. What's different about this, the one I just wrote, than the one that's printed there? 2 and 4, right? The bases are related there, right? And the way that we did this before was to say, well, 4 is 2 squared. So 4 to the x is 2 to the 2x. And that means that these have got to be the same, right? Okay. Well, that makes life a lot easier, right? Different here is that 2 and 5 don't have anything in common, right? There's no sort of common base that I can reduce those to that's going to work out in the same way. So we lose that as an option. Well, okay, let's figure out something else to do then. What do you want to do here? Before we get into, the details and the specifics of how things are going to work, big picture, what's the one thing that we're for sure going to have to do at some point? Take a log. Because we are trying to find an exponent that we don't know. Trying to find an exponent you don't know if you can't just guess it, right? Like 2 to the x equals 8 or something. Now one I can just guess, right? Because 8's 2 cubed, right? I know that. That one I can just guess. If I can't just guess it like this, then what we're going to have to do at some point is use a log. Okay, so we're going to have to use a log. How? Now let's worry about the details. Okay, so take the log base 2 there. Because what's going to happen to the left-hand side if you take the log base 2 of it? X plus 3 comes down. We get x plus 3 times the log base 2 of 2. But what's the log base 2 of 2? 1. So that's just x plus 3 on the left. Okay, cool. Well, that went really well. I feel good about how the left-hand side went, right? I had 2 to the x plus 3. I got to get x down somehow if I'm going to solve for it. I took the log base 2. The log base 2 and the exponential base 2, those are opposites or inverses, so they cancel. So you just get x plus 3 left. That's, again, good news. Like left-hand side couldn't have gone any better than that, right? But if you do the log base 2 to the left-hand side, you have to do the same thing to the right-hand side. And again, that's just the usual solving thing, right? You do something to one side of an equation, you got to do the same thing to the other side to keep it balanced. Okay, well, the left-hand side is not going to be quite, whatever this is. I'm using my left hand. I don't know. You guys know I don't know which one's which anymore. This side's not going to clean up quite as nicely, right? The log base 2 of 5 to the x. What happens there? What? Right, yeah. Some kind of, like, it's not just going to cancel because the bases aren't the same, right? The log and the exponential with the same base, those are inverses. With different bases, they're not. So what can we do to the right-hand side? Take the exponent and bring it down, right? Use the power rule. So x times the log base 2 of 5. Okay, so the right-hand side is x times the log base 2 of 5. Now, again, I might check here that the log of 5 divided by the log of 2, or if yours will let you do a different base directly, punch it in, big, messy decimal jumble crap. So I'm going to leave it like that, right? Okay. So the left-hand side, we've got x plus 3. 1x plus 3. The right-hand side, we've got this is 2 point something, but I'm going to leave it as an exact value. Again, this many x's. So we're going to treat that like it's a coefficient. If it helps you to, switch the order on them or whatever, it's multiplication, so it doesn't care what order you write it in. Treat this like a coefficient because it is. How would we solve for x there? How would you solve for x if it was x plus 3 equals 2x? Subtract x from here to here so that you get all of them on one side, right? Okay, we're going to do the same thing here. Three equals log base 2 of 5 x's minus x. Structurally, it's not any different than if it was just a 5 or just a 2 or whatever. So subtract from this side to move it over. Now here's where the sort of difference or where it starts to feel a little bit weird. This thing is again an exact value of some number that I can't really do anything else with. I'm stuck writing it this way. I can't really make it any prettier than it is right now. I've got that many x's and I want to take away 1, right? I'm trying to figure out what x is by itself. What I need to do is figure out how many of them there are now and then divide that out. So the only way that we can really do that is by factoring the x out of these two things, out of these two terms. There's the log base 2 of 5 of them here, and then minus 1 more. So factor this out and then leave that behind. This is how many of them there are. I want x by itself, so divide by it. 3 divided by the log base 2 of 5 minus 1. Yeah. Oh. So don't worry about the left and right part. Like you can switch them at will whenever you want, right? What we did to get x by itself here, this is x times some number, right? Admittedly a scary looking number, but it's x times some number. To get x by itself, I divide by whatever that number is, right? Like if this was 2x, I would divide by 2. It's this many x's, but I'm going to forget about the scary part while I can. It's that many x's, so divide by whatever that many is. So 3 divided by this whole thing is x4. And yeah, I switched the sides just because I want the right x equals, but yeah, don't worry about that part. Okay, so the initial thing, like where we started, again, we could use, and Christian, I think you said at the beginning, like we can use whatever base we want because we're the ones deciding to do the log, right? But choosing base 2 made the left-hand side of this thing clean up really nicely, right? The left-hand side, look at the beginning, is the one that looks a little bit more complicated, right? So if I choose the base so that that side cleans up, that's going to be kind of as good as it gets in terms of how complicated the rest of the stuff is going to be, right? The algebra stuff here, like this stuff is not easy, right? It's structurally not any different than just solving any other linear equation, but it feels and looks worse. I get that. This is, there's 1 or 2 of these in the homework. This is probably about the hardest thing that's in this chapter. But once you kind of get the feel for it and work through it, I think it's not as bad as it looks. But choosing the base here for this first step in such a way that the messier side cleans up faster is about is about all you can do in terms of making your life easy. So take a look at like number 6. What would be a good first step there? We're trying to find exponents we don't know, so we're going to have to use a log. What kind of log? Base 7 is going to make things go about as smoothly as they can, right? Now, there's kind of a limit on how smooth that's going to be, but that's going to be about as good as it gets. So that's what I would do, is take the log base 7 of both sides. Because if you do that, then the right-hand side is going to clean up nicely. The left-hand side, you're going to have to do, you know, similar sorts of things to what we just looked at. And then I'll leave, you know, the rest of the algebra to you, but you're going to do similar sorts of things to sort of finish that out, to clean it up from there. But using a log base 7 is going to make it go about as smoothly as it can. The like textbook or the help me solve this or whatever, when it goes through these, it always does it with like a neutral base, like an ln or a common log, which is perfectly fine. There's nothing wrong with that. It just gives you, it makes things sort of look a little bit worse all the way through, right? You have sort of log terms all over the place that you can't reduce. Okay. All right. So again, I'm going to leave that one for you. You can take a look at my stuff in Blackboard. We can talk about it tomorrow if we need to. But give those a shot. Again, I freely admit that exact kind of thing is probably about the most difficult thing you're going to see. You can use the same approach, by the way, for something like that, right? So here you can do the thing where you figure out a common base and use that to rewrite, and then like, you know, guess sort of what the exponent is by just setting the powers equal. You can take a log of both sides here too, though. Like that'll simplify it also. Here I would use like the log base 2, and then things are going to clean up nicely. Just for a minute, real quick. Let's take a look at going the other direction. So if you're solving a thing with a log in it, well, to get things out of the log, right? Like the thing I want to solve for is stuck inside this logarithm right now. To get things out of the log, you're going to have to go to an exponential. So the idea would basically be the same here. I want to start by getting that thing by itself. Then what? To make the log go away, I got to do the opposite. The opposite's the exponential. What's the base? LOG with no base written means the base is 10, right? And again, your calculator wants to remind you about that. That's why 10 to the x is on the same button, right? So base is 10. This would be 10 raised to the 2/3 equals x. And then again, I would just check 10 to the 2/3 and make sure it doesn't like simplify in a nice way. It doesn't. So that would be it. Now, again, you might have stuff to do, you know, on the front end before you can do that, because that's once you have the log all by itself, right? Or we might have stuff to do afterwards. So like, tell me about 8. The log thing is all by itself, so we don't have to do any sort of first, you know, setup type stuff. We've already got it alone. How would you rewrite that? 5 to the 3rd equals 8 minus 3x. But now we've got a little bit of stuff to do afterwards, right? 5 cubed is 125. Now this is turned into solving a linear equation, right? So solve for x now, subtract 8. Divide by -3. 39. I don't know. Yes, 39. So that would be it, right? So, but again, rewriting was the key step. And again, that might involve moving some stuff around first, or you might be able to do it directly. And again, maybe you rewrite it and then you're done, or maybe you have some stuff left to solve after that. But again, that step is kind of crucial to the whole thing. Okay, so there's that. Hang on to those. And keep an eye on email and stuff. If something happens, I will let you know what tomorrow is going to look like. If it's not going to be just a normal, I'll see you at 9 o'clock day. All right, so goodbye. I don't know. Have a good day. I'll see you tomorrow. Unless I don't. In which case.